Hello everyone, welcome to the second part of class 11 maths set chapter. In the previous class we have done what is a set, how to denote, what are the elements and key properties. In this class we will discuss set builder form and roster form of the sets. Means how set represent by set builder and roster form, and how to convert set builder to roster and roster to set builder. This is the important thing for your board exam. So look at the difference first. So we know that set is nothing but collection of well-defined objects. Okay. So how we are organizing that collection, based on that we have two options. Okay. So just see here, set is just a fancy way of organizing a collection of things. Now suppose think about a music playlist in your mobile. So you can either list every single song on the playlist. Okay, like this. If you are listing all the songs like this, then it is called roster form. Roster form means collection of every elements of that set. And another side we have, if you are listing or you are just describing the vibe. Okay, for example this 19's all the songs. Okay, so here we are just describing the vibes of the song. So that is called set builder form. Means here we are not listing all the elements or not listing all the songs. We are just describing that word that in this playlist all the 19 songs are there. Okay, so first is called roster, second is called set builder form. So let's look at mathematically what is the difference. So roster form means what? You list every single element of that set. That is called roster form. For example, the collection of all the vowels in the English alphabet. So that is A, E, I, O, U. So these are all the elements. Okay, so this is nothing but the example of roster form. And this curly bracket denotes the set form that we know. Okay. So here order is not important, that we have seen. Repetition is not allowed. Okay. So if you are collecting all the single element of the set, then it is called roster form. Now look at set builder form. Set builder form means what? We are not defining all the elements. We are just writing the condition or some important word of that. So instead of listing all elements, you write mathematical rule or description about that. Okay, that define what belongs in the set. So for example, that previous example that v is equal to, we have defined a, e, I, o, u. So here all the elements are there. This is called roster form. So what is the set builder form of this? So we can write down as v is equal to, this is a bracket of the set. So it is read as like this, the set of all the x such that. Okay, now this is called every element of x. Now this two dot is there, that is called such that. Now after that condition that x must be a vowel. Okay, in this set all these are vowels are there. So you have to write this x is what? X is describing here all the collection of vowels. Okay, so this is a set builder form. Here we have written the condition or the rule that describe this set. In this set means collection of vowels are there. So this is called set builder form. Okay, and how to read as x such that, this two dot means such that x is a vowel from the English alphabet. That means it is nothing but this set only. So both the set are same, but this is called roster form and this is called set builder form. So something, look at this table, what is the main difference and what you have to remember. So the approach, in the roster form we are listing the elements, in the set builder form we are describing the rule that describe all the element. Now which is best? Now roster form is best for small or finite set, means we are writing only some values, okay, which is stopping after some stage. In that case roster form is easy to write. And for large or infinite set, okay, for example the set which is never stopping or it is infinite, for that we are using set builder form. It is very easy to use like that. Example, set of all vowels in English alphabet, so it is only 5, no? So we can easily write all the elements a, e, I, o, u. Okay, but if you want to write down all the English alphabet, okay, then it is difficult, correct? So not difficult, but for that set builder form is easy to write. Okay, and this is the set builder form, that x such that x is a vowel in English. So suppose you have to write down all the English alphabet, then in the set builder form we will write x such that X is a English alphabet, all the English alphabet. Okay, so in word one condition will write all the alphabets here. Okay, now look at how to convert set builder to roster and roster to set builder. So whenever roster forms are given, roster form means elements are given and we have to convert into set builder form. So the first thing is you have to look at the pattern. What patterns are given in the numbers? Okay, that pattern you have to break and you have to convert into set builder form one by one. And the another way is set builder to roster. So set builder means one condition or one rule will be given. So you have to look at that rule and you have to apply that how the element will look like. So that all the element you have to write. So that is called set, roster form. So let's solve the questions one by one. So look at the first. So what you can see, this is nothing but roster form is given. Okay, we are converting roster to set builder first. So a set is given 3, 6, 9, 12. 4 elements are given. So we have to look at the pattern and then we have to convert into set builder form. So what is the pattern here? 3. 3 can be written as 3 multiplied by 1, which is 3. Then 6. 6 is nothing but 3 to the. Then 9. So 9 can be written as 9 into, sorry, 3 into 3. After that 12 is there, that means nothing but 3 into 4. Okay. So what is the pattern? You can see that in all these numbers, 3 is common here. 3, 3, 3 is common. Only after that multiplication is also common. After that, after multiplication, whatever number is there, that is changing. 1, 2, 3, 4. Okay. So how to write the set builder form, that I will tell you. Okay, the set is given a, so that will be as it is a, then set bracket, after that you will write x, then such that, okay, then again x. So till here it is common in every question, x such that x. After that we have to write down is equal to, now the common condition. So what is common here? 3 is common, so we will write 3. After that multiplication is common, so multiplication. Then what is changing? This multiplication number is changing. So whatever number is changing, instead of that we will write n. Okay, whatever number is changing, instead of that we will write n. Now how many numbers are changing? 1, 2, 3, 4. That means the n is not all the numbers. We have to take n is nothing but 1, 2, 3, 4. Okay, either you can write down like this 1, 2, 3, 4, or we can write down like this, that n is between 1 and 4. Okay, so in the simple way, x such that x is equal to 3n comma n is 1, 2, 3, 4. The n value we have to take only 4. 1, 2, 3, 4. If you put n is equal to 1, we'll get 3. If you put 2, we'll get 9, 6. And if you put 3, we'll get 9. And if you put n is equal to 4, we'll get 12. Okay, so this is the set builder form. Look at the second question. B is equal to given 1, 4, 9, 16 and 25. So if you look at carefully, these numbers are nothing but a perfect square numbers. So 1 is nothing but 1 square is 1. 4 is nothing but, how to write 4? 2 square, then is 4. So how to write 9? 9 means nothing but 3 square. 25 means 5 square. So what is the common here? You can see that power is common here. 2 is common in the power. Okay. So how to write set builder form? B is equal to x such that x is equal to, now what is common? Power is common. Okay, so in the power 2 is fixed. Now what is changing? The base number is changing. 1, 2, 3, 4 is also there and 5. Okay, so whatever is changing in that, instead of that we have to write down what? N. So x is equal to what will come? N square. Okay, then comma, now that n, whatever number is changing, so it is changing from where to where? N is, which value n is taking? 1, 2, 3, 4 is also there and 5. So n is taking only 4 values. So we have to write down 1, 2, 3, 4 and 5. Okay, if you don't want to write down like this, then you can write down like this: 1 less than equal to n less than equal to 5. That means n is taking 1 to 5, all the values. And yeah, you have to write down this also: n belongs to natural number. Okay, otherwise if you're writing only this thing, that means every number will come between 1 and 5, 1.5. Okay, decimal number also come. So this is important. We have to write down n belongs to natural number. Okay, and if you don't write down n belongs to natural number, then you just list the element n is equal to 1, 2, 3, 4, 5 like this. Okay, so this is a simple way to write roster form. Look at the next question. one set is given C, so numbers are given 2, 4, 8, 16 and 32. So this is not a table of 2 actually, it is a power of 2. You have to see the pattern. So 2 can be written as 2 raised to 1, 4 can be written as 2 raised to 2, 8 can be written as 2 raised to 3, 16 is 2 raised to 4 and 32 is 2 raised to 5. So what is fixed value here? The base number 2 is fixed. Okay. What is changing? Power is changing. So how to write this set builder form? C is equal to set bracket x, then such that x is equal to this much, it is fixed. Then the base number is fixed, which is 2. So we have to write down 2 fixed. Now what is changing? Power is changing. So instead of that we have to write down n. After that comma, so that n is taking which values? N is 1, 2, 3, 4 and 5. So here we have to write down 1, 2, 3, 4, 5. Done. Okay. Otherwise, if you don't want to write down like this, then write down n belongs to natural number, but not all the natural number. We want only the natural number which is starting from 1 to 5. Look at the fourth question. D set is given 5, 10, 15, 20 and dot 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 so on. Okay. So if you look at the pattern, 5 is nothing but 5 ones are, 10 means 5 twos are, 15 is 5 threes are, then 20 is 5 into 4. So it is nothing but table of 5. So 5 is common here, multiplication is common, only the multiplication number is changing from 1, 2, 3, 4 and so on. Okay, now look at the set properly. Here dot 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 word is there. Okay, so it is not stopping here, it is continue. After 20, 25, 30, 35, 40, 45, 50, 55, 60 and so on. It is continue, it is not stopping. So only 4 elements are not there here, infinite elements are there. Okay, so how to write this set as a cell builder form? So D is equal to set bracket x such that x is equal to, now what is fixed here? 5 is fixed, so we'll write 5, then multiply by, after multiplication number is changing, so instead of that we'll write n, comma, so n is equal to, now n is taking which values? 1, 2, 3, 4 and so on, it is taking, go on. So we'll write 1, 2, 3 dot 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 like this. Okay, and 1, 2, 3 dot 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 infinite value, that means it is nothing but n belongs to natural number. So either you can write down like this or you can write down n belongs to natural number simply. Okay. Look at the next question. Now suppose numbers are not given, some alphabets are given. So set E is equal to, like this alphabets are given and we have to convert this in terms of set builder form. So you can see that what letters are given: alphabet M, A, T, H, E, I, E, C, S. Okay, so this is nothing but the alphabet of word mathematics. Okay, so if we write in the set builder form, E is equal to X such that we can write down X is nothing but, now number is not there, so we will write X is a letter in the word mathematics. Okay, so if you see this word, all the letters are mentioned here: M, A, T, H, E, I, C, S. Okay, so here M is coming twice, but in the set bracket, in the set we are writing only one times, correct? So in the roster form we are writing only one times. This is the word mathematics. Okay, so this is how to write whenever alphabets are given, then in the set builder form. Look at the next. Now part B, how to convert set builder to roster. Okay, so look at the set. One set is given f such that x is an integer and -3 less than x less than 4. Okay, so x is an integer, that is the first condition, and the integer is between which number? -3 to 4. So we know that integer means all the positive value, negative value and including 0. Okay, so if I draw the number line, let's say -3 is here, so after -3, -2, then -1, 0, 1, 2, 3, 4. Okay, so we required which integers? We required integers between -3 and 4. So between -3 and 4, which integers are there? -2, -1, 0, 1, 2 and 3. Okay, this -3 and -4 won't come because here strictly less than sign is there. That means that end points are not included here. Okay, so if you write the roster form, that means we have to write all the elements only. Okay, so what are the elements of this set? -2, -1, 0, 1, 2 and 3. Done. Look at the next question. G set is given, G is equal to X such that X is equal to 2n plus 1. Okay, this is the one condition, 2n plus 1, where n belongs to W. W means whole number. Okay, so whole number is starting from where? 0. And one more condition is given, that n must be less than 4. Okay, so n is whole number and less than 4. So whole number is what? 0, 1, 2, 3, 4, 5 and so on dot dot dot. But we required how many number? Less than 4. So less than 4 means only 0 to 3. Okay, so n is taking only 4 numbers: 0, 1, 2 and 3. So what is the condition is given? X is equal to 2n plus 1. So if we put n is equal to 0, okay, so 2 into 0, which is 0, plus 1, so we'll get 1. So our first element is 1. Now put n is equal to 1. So 2 into 1, 2, and plus 1, which is 3. So second element is 3. Then put n is equal to 2. So 2 into 2, 4, 4 plus 1 is 5. So third element is 5. Then put n is equal to 3. So 2 into 3, 6, 6 plus 1, 7. So next element is 7. Now we cannot take 4 because 4 is not the real. Okay, we have to take only number which is less than 4. Okay. So this is the roster form. Look at the next question. Again the same thing, H set is given, X such that X is a prime number which is divisor of 60. Okay, so which number divides 60? The divisor of 60, if we look at, okay, or if we do the prime factorization of 60, okay, so 2 30s are, then 15 into 2, and then 3 into 5 and 5 into 1. So what are the prime numbers we are getting? 2, 3 and 5. Okay, we want only prime numbers which divides 60. Okay, so which numbers will come in this set? 2, 3 and 5. So this is our roster form. Correct. Look at the next question. Set is given I is equal to X such that X is a 2-digit natural number such that the sum of the digit is 8. Okay, so sum we require 8. So which two number? Okay, 2-digit number is starting from where? 2-digit number starting from 10. Okay, so 1 plus 0, that is 1, but we want sum is 8. So which number you will add? So you will get sum 8, that numbers we want. Okay, so the first number will get 17. So 1 plus 7, which is equal to 8. So if 17 is there, then 71 is also there, no? Okay, so 17 and 71, then the pattern is you just increase by first number by 1, so it is 2, and decrease second number by 1, so it is 6. So 2 plus 6, which is also 8. So 26 is there, then 62 is also, sum is 8, correct? So 17, then 26, 71 and 62. Similarly, increase 2 by 3 and decrease 6 by 1, so 35. Okay, so 3 plus 5, which is also 8. So if 3 plus 5 is 8, then 5 plus 3 is also 8. So 35 and 53, that both number will come. Okay, and which number else remaining? 44, 4 plus 4, which is also 8, and one more number, 80. Okay, so 8 plus 0, which is also 8. So 80 we have taken, but we cannot take 08 also, because 08 is a 1-digit number. Okay, so 80 only will come. So these are the elements of this set I, and this is a roster form. Look at the next question. Question number 10. X is equal to X such that X square less than equal to 4, comma X belongs to Z. Z means integer. Okay, so we have to write down all the elements which satisfy this condition, and that number must be integer. Okay, so square of that number is less than equal to 4. So integer is starting from 0, not starting from 0, it is 0, negative as well as positive. For example, if I take x to be 1, so 1 square is what? 1, which is less than equal to 4, yes, so we can take 1. If we take 0, so 0 square is what? 0, which is less than equal to 4, yes, so we can take 0 also. If we take 2, so 2 square is what? 4, so 4 is less than equal to 4, yes, why? Because here is equal to sign is also there, so we can take 4. Okay, that means 2 element belongs to the set, because 2 square is 4. Okay, So whatever number we are taking and their square is less than 4, that all the numbers will come. Okay. Similarly, minus 1. Can we take minus 1? So let's check. So minus 1 the whole square, which is 1, and 1 is less than equal to 4. So minus 1 is also come. Okay. So minus 1 will come. Similarly, minus 2 will also come because minus 2 square is 4 and 4 less than equal to 4. Equal to sign is also there, so we can take minus 2. Now can we take minus 3? So minus 3 square, which is nothing but 9. So 9 is less than equal to 4? No. So minus 3 we cannot take. Okay. Similarly, minus 3, minus 4, this number we cannot take. But minus 2, minus 1, 0, 1, 2, 3. Okay, 3 also not there. Okay. So minus 2 square, which is 4, that we can take, less than equal to 4. Minus 1, that we can take, 0, 1, and 2. So the roster form this set is nothing but minus 2, minus 1, 0, 1, and 2. Okay. If you do the square of each number, that will be less than equal to 4. Satisfy this condition. So this is the roster form. Okay. So this is the thing, roster form and set builder form. If you like this video, then share with your friend and do not forget to subscribe. Thank you.